So, were you to ask most people, whether those people happen to be alive or dead, whether in the past or in the present, what makes humans unique as a species? Many people that you ask would rather correctly, I think, reference our relatively large, superior intellect, our brains. Humans are a relatively smart species, all things considered, at least compared to other species on this planet. And we've used that intelligence in combination with our ability to do things like share knowledge and make tools to massively shape the globe and life on it, whether for better or worse. Yet, if you dig through the psychological literature that's out there for a while, as I have, you'll almost certainly notice a very interesting trend in this psychology literature, which is this immense capacity to catalog cognitive biases. Check, there's one site called the Decision Lab. Their website currently listed over 100 cognitive biases that usually focuses on things people do that yield suboptimal outcomes, and I suspect that their list is hardly a complete one. Wikipedia has a similarly impressive list of cognitive biases, as well as a separate list of reasoning fallacies that people employ on a fairly regular basis. And an impressive quantity of psychological literature research appears aimed at documenting various human mental missteps. A lot of psychology research focuses on documenting and labeling these type of biases. That is, the way in which humanity tends to deviate from logical, rational thinking. That's what a bias tends to be. Indeed, this same Wikipedia page that we're looking at right now, the one that catalogs a lot of these biases, defines the cognitive biases as systematic patterns of deviations from norms and or rationality in judgments. The core concept here is that were people being rational, they would have settled on different answers, but we have these cognitive biases that make us not rational. So why is it, on the one hand, that so many people would say humans seem so intelligent and this is what defines us as a species, yet on the other, humans appear to be so poor at being rational, logical thinkers? It's a very interesting contradiction there. Now, we reviewed part of the answer to that question in previous lectures, and it's always worth briefly reviewing that as we move forward here. The general answer is that our psychology did not evolve as this general purpose tool that solves all problems equally well. Instead, it evolved as a series of different mental organs that specialize in solving rather specific adaptive problems. And this is exactly how the rest of our body works as well. We don't have one general purpose organ in our body. We have a variety of different organs that specialize in a variety of different tasks. We don't have one mind, we have a lot of different pieces, a lot of different mental organs that make up our brain. As such, our perspectives on the functioning of our psychology will depend on what functional perspective we're using to interpret what we're seeing. If your perspective is that the human mind functions as this single general problem solver, and it applies the same domain general processes like logic or reasoning in service of obtaining some accurate information, then our brain may end up looking like this tangled mess of irrationality and biases and mistakes. It's not going to look particularly well suited at completing the task it's supposed to do. By contrast, if you view the mind as containing a great many different functional pieces that each evolve to solve specific adaptive tasks, it should really come as no surprise that attempting to apply the tools to tasks that don't fit their proper contexts can make people end up looking rather silly and quirky. So, reviewing our Wason selection task as one example here, the task is that you have 4 cards in front of you. Each of these cards has, in the first case, a letter on the front and a number on the other side. And you give people some abstract rule. Like every card that has an A on one side must have a 7 on the other. And you ask them, What's the minimum number of cards you have to turn over to check to see if this rule is true? Most people are going to correctly select the A card, because if the A doesn't have a 7 on the back of it, then there is a violation of the rule. And most people will then also incorrectly select the card that says 7. The A is correct because, again, if there's a 7 on the other side, the rule is disproven, but the 7 is not the correct card to flip over, because the rule doesn't say every card that has a 7 must have an A. It says every card that has an A must have a 7. So if there's a card that says B and 7, that doesn't violate the rule. The card you have to flip over here would be the 2, because if there's an A on the other side of the 2, that means the rule was proven wrong. This is a reasoning task. It's a logical task. And performance on this task seems really, really poor. On this task, humans seem irrational and illogical. But is that because our intelligence is faulty, that there are some biases here, or because the assumptions we're making about what the brain is supposed to be doing, what problems it's supposed to be solving, and how it does that are wrong? That is, if we handed our brain a task that we were never prepared to deal with in the first place, wouldn't it be understandable that performance on that task is poor? And as it turns out, when you give people the exact same logical puzzle, but you frame it in terms of detecting social cheaters, humans become very skilled at this task. That's the bottom task. So you tell people that you're a bouncer at a bar, and you need to check the rule: if someone is drinking alcohol, they must be at least 21 years old. All of a sudden, people become very skilled reasoners in this domain, and they're very logical thinkers. And they flip over the alcohol card, because if someone's under 21, the rule is violated, and they flip over the card that says 19, because if the 19-year-old is drinking alcohol, that violates the rule as well. And this is really an important example for driving home this point. Our cognitive tools are functionally specified. They're attempting to solve specific problems rather than general ones. Whether our reasoning in these tasks is going to look like a flaw or a design feature depends heavily on the context and assumptions the researcher has in mind. Or to put this in a more concrete example, just to make this easy to understand, a steak knife might look like it's a very poor cutting implement if you're assessing its efficiency at cutting down a tree, whereas a chainsaw might seem like a really poor tool to cut your dinner at the table. It's not because there's a flaw in the design of either cutting implement, it's just because each cutting implement is designed to solve different functional tasks. If you assume the knife is going to cut everything equally as well, you're going to make a mistake, and if you assume the chainsaw is appropriate for all tasks, you're going to make a mistake too. Because most psychology researchers don't know how to ask these questions of functionality in the first place, or how to ask them well if they bother to ask the question at all, this is why we end up with this list of biases and heuristics and shortcuts and flaws in the human reasoning. This is why people think of them as flaws, something wrong. The mind ends up looking like this complete mess because people are working under the wrong functional framework. So with that in mind, today I wanted to review a very interesting idea, very interesting paper by two authors, Mercer and Sperber. It's from 2011. And it asks about the adaptive functioning of the human reasoning abilities themselves. Specifically, what does it mean to reason? How do humans reason? And why do humans reason? That is, what is the adaptive function of our reasoning abilities, and how does this function inform our understanding of the way we actually go about the process? So the first question: what is reasoning? This is somewhat simple to tackle, so we can just start there so we know what we're talking about. Mercer and Sperber define reasoning as the following process. It's the generation of a new mental representation, a new idea in your head, in this case, a conclusion, a generation of a conclusion that is produced and reaches conscious awareness. So it's a conscious process of reaching a conclusion based on premises that warrant those conclusions, which are also consciously entertained. Reasoning is so named because we have a conscious awareness of both the conclusion and the reasons for that conclusion. So put in abstract form, reasoning follows this idea that as you're thinking consciously, if A is true and if B is true, then it follows that we should reach some conclusion C. In this case, A and B are seen as the reasons for accepting C, hence the name reasoning. Reasoning, in their view, is the mental action of producing convincing arguments for a conclusion and the public action of verbally producing them to others. You can see this is summed up by Descartes here, classic example of reasoning. I think, therefore I am. I have a conclusion, I exist. The reason I think this is that I am thinking. Because I am thinking, I must exist. Classic reasoning. And we can differentiate this reasoning process from other processes of inference. And an inference is just when you have a cognitive output being produced by an input. For instance, if you have some wavelengths of light entering your eye, that light is then processed by certain mechanisms in your eye and later in your brain, you will create the inference that you are perceiving an object, or that this object that you're perceiving is a human, and that human is a sister and that she is approximately 15 feet away from you. These are all inferences, new mental representations based on inputs. And these inferences are usually created without any conscious awareness that a process has even taken place. And you don't base your perceptions on any type of consciously entertained reasons for them. You just see things. You don't need to reason your way into seeing things. It just happens. It's an automatic process. Reasoning is a more consciously entertained type of thing. Now, in some sense, reasoning is going to depend on our intuitive inferences. Our reasons for thinking what we do are often based on these unconscious processes. However, what Mercer and Sperber set out to do is explain why do people consciously reflect on the reasons for accepting or rejecting certain conclusions? And why do we attempt to determine if the conclusions are good or justified? The answer that they propose is a relatively simple one, though it's counterintuitive to many people, which is that we reason not necessarily to discover the truth, but rather to argue, or more specifically, to persuade other people and be persuaded by them. This is their proposed function. It's not about finding truth, it's about persuasion. And I say that this function is rather counterintuitive because a common view of human reasoning is that it's there to enhance our cognitive abilities to discover things, to learn new and accurate information about the world, to improve our thought processes. In other words, many people think we reason to correct our intuitions. And this view looks at reasoning as a very type of solitary activity, something that occurs inside of our own mind, focused on our own thoughts and our own feelings. And as Mercer and Sperber note, that may occasionally happen. Our reasoning abilities may sometimes produce new knowledge or correct internal mistakes, but they question whether this is the primary function of our reasoning abilities. Relative to the times that reasoning does things like, say, produce new mistakes, or reasoning justifies our initial intuitions. That is, they're asking a question as to whether reasoning seems particularly well designed for improving our knowledge to the point that warrants it being considered its primary function. Are we reasoning because we're improving knowledge? And if we are, how well does that fit with the ways we actually reason? And is reasoning actually improving our knowledge here? So instead, they propose the following framework, and it starts with communication. Humans communicate with each other very regularly. We're communicating right now. Information is passed from one person to another, frequently through speech. However, for communication to be adaptive and to continue, for people to be selected to communicate, the communication needs to benefit both the sender and the receiver of this information. If the senders don't benefit from communicating, they're just going to stop communicating. They're going to stop sending any signals because there's no adaptive benefit to doing so. And if the receivers don't benefit from receiving this information, they simply don't pay attention to it. So to keep this simple, and in line with our previous examples, I want to think again just about peacock tail feathers, because they are a type of communication. Male peacocks are sending information about their physical and genetic robustness by displaying these feathers. Since a bird that's in relatively poor condition, in poor health, can't bear the costs imposed by the feathers easily. Now, the peacocks aren't thinking about sending this information, but this is a form of communication. So it benefits the male peacocks to grow and display these tail feathers because communicating this information to peahens, the females of the species, improves the male's likelihood of mating successfully. By communicating this information, the males gain a mating benefit, and as such, communication is benefiting the sender. However, for this to work, the communication also needs to benefit the receivers, the females, the peahens. And in this case, when the females attend to this information, when they pay attention to it and they are persuaded by it, the peahens are better able to select partners that are in better condition and are better able to overcome the adaptive struggles of life. And in turn, by changing their mating decision on the basis of this communicated information, the females can produce better offspring than they may otherwise. So here we have this great example of nonverbal communication, where information is being passed between a sender and a receiver. Both the sender and the receiver are benefiting from this interaction. And that's great. Works out nicely. However, if the males could not gain a benefit from sending this information, that is, if the females did not pay attention to these tail feathers, the males couldn't have evolved the tail feathers to begin with. It has to benefit the males to be able to send this information to the females. And likewise, if the females didn't gain from receiving this information in some capacity, the tail feathers didn't communicate some relevant traits or outcomes, the females simply wouldn't pay attention to this information. They would not be selected to attend to it and use that information to change their behavior. Because if you're paying attention to useless information, you're not going to end up with better behavioral outcomes. Again, the communication has to benefit both the sender and the receiver. Now, a major problem that humans are going to encounter when we're communicating, especially when we're communicating with speech, when we're communicating verbally, is that there is nothing keeping that speech honest. Relative to cases of costly biological signals, like the peacock tail, where the signal is honest because it is difficult physically to bear it. It is physically costly to send the signal. It's very easy for me to tell you that I'm poor or I'm rich. It doesn't cost me anything more or less to say one of these things. It's as easy for me to tell you that I'm loyal as it is for me to tell you that I am disloyal. So while speech can offer some really massive benefits to allow all types of information to be sent and received very quickly at little cost, it also allows a massive risk to enter this communication equation, because you can be deceived or manipulated into acting on false information. This means when other people are communicating with you, they're trying to send you information. You need to be able to check this information for accuracy to avoid being misled. You have to be able to separate out the accurate, useful information and reap its benefits, and separate that out from the false information and avoid the false information's costs. If I tell you I'm rich and I'm actually poor, and you treat me like I'm rich, you might be inclined to give me benefits you otherwise wouldn't because I'm not going to repay them. That's a risk you have to avoid. Operating on false or misleading information is quite costly because it's going to make you make inaccurate predictions about the world, make inaccurate predictions about the outcomes of your behavior, and cause you to allocate your time and energy and effort poorly. If you just think about any scam emails coming from some Nigerian prince that's promising you massive financial rewards, if you only send them money now, you really get the picture about the risks of being misled in communication. It's very easy to send that information, and so there's nothing keeping it honest. So reasoning, in the view of the authors here, can serve your interests as both a receiver of information by helping you check it for accuracy, because when there are good, convincing reasons for accepting that information, you let it through. And when those reasons aren't sufficient, you can block it off. So reasoning is helping receivers of information get accurate information and avoid inaccurate information. However, as we noted, communication is this two-way street. It needs to benefit the people that are sending this information as well. And there are a variety of reasons that people sending information might want to put that information into the minds of others. And all of those tend to have to do with changing the behavior of the person getting the information. That is, what are the benefits to the senders of information? What benefits do I reap by teaching people and communicating them? Question we ought to answer. So if I benefit from, say, you being alive, you're related to me, you're a family member, a child, a parent, whatever. If I benefit from you being alive because you're related to me and our genetic interests are overlapping here, I can benefit myself by providing you with useful information that helps your survival prospects. Or in another less altruistic example, I might benefit myself by convincing someone else that I'm a really great social investment for them. Because if I'm a great social investment for them, they should provide me with benefits. And this can be beneficial for me even if I'm an awful social investment. But so long as they believe the information I'm sending them and act on it, the changes in their behavior can still benefit me regardless of whether the information I'm sending them is true or false. So as such here, reasoning can also benefit the senders of information by helping them produce more convincing reasons for its acceptance. If I can think up a convincing enough reason for you to accept what I'm telling you, I can more easily put information in your head and affect your behavior in ways that can benefit me. And in this light, the argumentative function of reasoning that they propose becomes clearer. The function of reasoning in this view isn't some solitary process for improving the accuracy of our own beliefs, but rather reasoning is a social process that helps us persuade others of things and be persuaded ourselves when appropriate. So if this functional explanation is accurate, naturally there should be some good reasons for accepting it. Reasoning abilities should look like they behave more efficiently in the context of arguments and persuasions relative to other non-argumentative contexts. And in that light, biases and fallacies of reasoning may begin to look less like flaws in a system designed to produce truth and start to look more like features in a system designed for persuasion. So we can start with the fact that reasoning in some non-argumentative abstract context seems rather poor, which we've already reviewed today. There's the Wason selection task. This is a non-argumentative context. It's just an abstract reasoning logical problem. And when placed into these purely abstract contexts, people tend to fail at reasoning tasks in terms of getting the answer accurately, regularly. Left to our own devices, we fail all the time. When you take that same task and you place it in the context of detecting cheaters, performance skyrockets. You need the right context. So as an additional piece of this puzzle that Mercer and Sperber bring to bear is looking at how argumentation and persuasion can improve performance on these reasoning tasks. Specifically, they highlight some tasks, a specific type of task, which is a logical task with an objectively correct answer, so you can actually see if people are getting it right. And you have people try to solve that task when they're on their own. Then they discuss their solutions in a group of other people, say 4 or 5 people, and then everyone goes to solve it alone again, and see how the performance changes. What tends to be found in these contexts is that initially most people get the wrong answers. But once they come together in a group to discuss their answers, that is, they start employing their reasoning abilities with other people that may have come to different answers with different reasons for reaching those conclusions, accuracy subsequently skyrockets. So this is really to say that when people have the correct answer, they tend to be able to persuade other group members that their answer is correct and why. And accuracy in this case can go up from 10% when solved alone to 80% after discussion in a group. And importantly, this performance increase can occur even when none of the group members actually has the right answer. They all just have to have different pieces of the answer. So long as some group members have a partially correct answer and good reasons for thinking that part is correct, they're able to persuade others, and when other people have good reasons, they're willing to be persuaded themselves. Reasoning is certainly at least capable of changing people's minds, so part of this function is at least so far consistent with what we know about how reasoning works. Now that's all well and good when we're talking about reasoning contexts where there is some disagreement over what the correct answer happens to be. Everybody involved in this discussion has some interest in uncovering what the actual correct answer is, and none of them have any particularly vested interest in what that answer happens to be. Very few people have strong feelings about the outcome of a Wason selection task, of some abstract logical reasoning problem. That task also happens to have an objective answer, and so groups tend to converge on the correct solution. When those conditions aren't met, however, reasoning may not be employed at all, or reasoning may be employed in a manner which leads to better persuasion without necessarily enhancing accuracy. So we're going to put this in some examples. That we have many situations in which there's no disagreement in the first place. And when there's no disagreement, people's reasoning mechanisms tend to not be as actively engaged. And there are also going to be situations where people come to discussions with a particularly vested interest in what conclusion is reached. And these are going to place the goals of persuasion and accuracy at cross purposes. And finally, we're going to look at some situations where there aren't clear objective answers, like a logical reasoning problem. And when there aren't clear objective answers, this may cause some people to accept conclusions that are easier to justify without necessarily being better. So let's take a look at each of these in turn. We can first consider what's referred to as confirmation bias, which is defined as people seeking or interpreting evidence in ways that confirm or support their existing beliefs. They come to a task believing something, and they look for evidence to support that belief or make it fit to that belief. So to see confirmation bias in action, we're going to look at two studies here, which use the same experimental setup. And that setup is the following. A participant's going to come into the lab, and the experimenter is going to present them with three numbers, which you can see here, in this case, 2, 4, and 6. The experimenter tells the participant that these three numbers were generated using a hidden rule. The experimenter knows what this rule is, and it's the participant's job to try and figure out what that hidden rule is. And to do so, they're able to collect evidence and test their ideas. How do participants do this? Well, they do the following. You give the participant a piece of paper, and you say, I want you to write down what you think the hidden rule might be, and then you generate three numbers of your own. Then the experimenter will look at those three numbers, and they will tell the participant whether those three numbers correspond to the hidden rule or not. So the participant might say, give you the numbers 1, 2, 3. And then the experimenter will either say, yes, the hidden rule can be consistent with 1, 2, and 3, or no, the hidden rule is not consistent with 1, 2, or 3. So participants are trying to collect evidence to find out what this hidden rule is. This is a lot like what scientists are supposed to be doing. They observe something in the world, in this case, a string of numbers and a hidden rule generating them. and they're trying to figure out what thing in the world is causing that outcome. So they go out and they collect evidence as to what's causing that outcome to happen and see if the evidence is consistent with their idea or not. So participants are trying to be good little scientists here and figure out what natural law is causing these rules, these numbers to be generated by these rules. So in the first of these two studies I want to review, this one was written by Fenna-Poltek in 1996. They examined 3 different conditions. In the first of experimental conditions, participants saw 2, 4, 6, and they're just asked to test their guesses. They're not given any more instructions beyond that. Just how the task works, test your guess. This is like the default condition. What do people do left to their own devices? In the second and third conditions in this study, they were given explicit instructions to either try and confirm your hypothesis or to prove your hypothesis wrong, to disconfirm your hypothesis. So the 3 conditions are test your rule, confirm your rule, or disconfirm your rule. Try and prove yourself right or wrong. So when you tell participants to just test their guess without any additional instructions, the things participants do really mirror what happens when you tell them to explicitly confirm their rule. Whether you tell people to just test their rule or whether you tell them to try and confirm their rule, in both cases, participants will overwhelmingly present strings of numbers to the experimenter that conform to their guess as to what the rule is. So putting this in a concrete example, making this a little less abstract, participant sees 2, 4, and 6. And what stands out to them is that these numbers are all even numbers, and they're all increasing by 2. So the participants guess the rule, and their guess is even numbers increasing by 2. And if that was their guess, they might try to present strings that conform to their rule, like 4, 6, and 8. And the experimenter will tell them, yes, that's valid. Then they'll propose a second sequence that also confirms their rule, 12, 14, 16. And the experimenter says, yes, that's also true. This is about what 95% of the participants in both of those conditions did. They took strings that were consistent with the rule they guessed. They were independently and continuously seeking evidence consistent with their guess. Now, in some sense, that's really not that bad of a strategy to start with. Because after all, if a sequence of 4, 6, and 8 was rejected, this would tell them at least something about their guess was wrong. The confirmation bias kicks in when people don't try to prove their guesses wrong on their own. Left to their own devices, people are not trying to prove themselves wrong. That is, perhaps the rule that generated 2, 4, and 6 is even numbers increasing by 2. But the rule might also be any numbers increasing by 2, or any even numbers, or any 3 numbers that are increasing, or any 3 numbers at all. The sequences that participants are proposing are consistent with their own guesses, but they're not trying to rule out any alternatives that are also consistent. What they're looking for is evidence consistent with their own guess. They do this when you tell them just test your idea or confirm your idea. Indeed, even when you ask people to explicitly prove themselves wrong, only about 60% of the participants proposed a negative test at all, one that might prove them wrong, one that was inconsistent with the rule they were guessing. 4 out of 10 people didn't do this. But even when participants did manage to propose a number sequence that was inconsistent with their own guess, they actually didn't expect that the experimenter would tell them, yes, this is acceptable. So if the participant was guessing even numbers increasing by 2, and they guessed 1, 3, and 5, they were expecting that the experimenter would say, no, that doesn't work. And this is kind of important because it seems to suggest that the participants that were making these negative tests, the one inconsistent with their rule, they were actually expecting the negative test to confirm their original prediction. They weren't really trying to prove themselves wrong, they were just trying to prove themselves right in a slightly different way. So again, to put this in an example, if you thought the rule was even numbers increasing by 2, the negative test would be, say, 1, 3, and 5. Because now the numbers aren't even anymore, so if that string is acceptable, then your original rule is at least partially proven wrong. But even if participants were able to propose that, they didn't expect that the experimenter would say, yes, 1, 3, 5 is acceptable. So really they were just trying to confirm their original guess, even when they were trying a negative test. Now, to be clear, this isn't just because people are bad at negative tests. This isn't because people are just bad at falsification across the board. We can actually be quite good at this in the context of trying to prove other people wrong. It's where the idea is our own that things start to get sticky. And this is where our second study comes in. This is from Crowley and Byrne in 2005. And there were 2 experiments in this paper. The first of these, again, participants see this 2, 4, 6 task we just discussed. But the key difference here is, in one condition, they were told about a guess made by a hypothetical person, Peter. Peter made a guess about what rule is generating these numbers. And they were also told this is what the actual rule is. So in this case, the actual rule of the task is any 3 numbers that are increasing. As long as you have any 3 numbers that are getting larger, it's an acceptable string. So participants know what the rule is, and they're told about Peter's guess, which is even numbers increasing by 2. When they know this, 90% of participants are actually able to provide a good falsification test, where they propose a string that is inconsistent with what Peter thinks, actually consistent with the rule, and they expect, or rather in this case know, that the rule is going to prove Peter wrong. They expect that the string they propose is going to work. So they might propose 1, 3, 5, or 1, 2, 3, something like this, that's going to be inconsistent with Peter's rule, but actually consistent with the experimenter's rule. People know how to falsify in some cases. So what happened in the second experiment, again, you have this same setup, 2, 4, 6. Half of the participants here are told Peter came up with this idea, that numbers are ascending in 2 and they're even. Even numbers ascending by 2. The other half of participants were told by the experimenter, your guess is even numbers increasing by 2. So everything's the same, except in one case the experimenter said Peter's guess is, in the other condition they said your guess is. So your job is to test the rule, as before. So even in this case where people weren't coming up with their own hypotheses, they were just told what their hypotheses were, there were major differences that were emerging between these cases. Participants that were testing someone else's guess tried to falsify it 32% of the time. People testing their own guess tried to falsify it 7% of the time. Participants were also more likely to abandon someone else's hypothesis. That is, after people tested, 62% of the participants said even numbers increasing by 2 was not the hidden rule if they thought it was coming from someone else, if they thought Peter proposed it. But if the experimenter said your guess was even numbers increasing by 2, only 25% of people abandoned it. 62% abandoned someone else's idea, 25% abandoned their own. About 2.5 times more likely to give up someone else's idea than your own in that experiment. Great example of confirmation bias in action. And this is important because in the context of reasoning, being some type of truth-improving tool, or some thought-enhancing tool, or some accuracy-improving tool, these findings seem like failings, and they seem like biases. It seems like the reasoning part of the brain isn't functioning properly. However, if we conceive of reasoning that function to be persuasion, all of a sudden these findings start to make a lot more sense. Mercer and Sperber are noting here that when people aren't placed into argumentative contexts, their reasoning abilities don't seem to be engaged as productively. That is, when people have a particular intuition or a particular conclusion in mind, they do not spontaneously try to prove themselves wrong all that often. And in fact, even when you explicitly tell people to try and prove themselves wrong, to try and falsify their own ideas, they don't really seem to be very good at it. When someone is producing an argument, producing reasons that other people should accept their conclusions, what people try to do is look for evidence consistent with their view, evidence that favors their view. Because providing evidence that you're correct, more likely to persuade. Providing evidence that you are wrong, less likely to persuade. And the one context in which people tend to think about arguing against their own points doesn't tend to be when people are actually trying to argue against their own points, but rather when people are anticipating having to defend their conclusions with other people who disagree. That is, some people might try to imagine arguments against their own points if they're imagining arguing with someone else. That is, what reasons is someone else going to give for rejecting my conclusions? And how do I anticipate and overcome those? But in those cases, people don't really consider arguments against their own points as really being arguments against their own points. They look at those as obstacles they have to overcome and points to be rebutted. People aren't really arguing with themselves as much as they're looking for more reasons to accept the things they already believe. Where things really change is when one stops producing this information and starts being the receiver of this information. That is, when those ideas are coming from somebody else. And in those contexts, confirmation bias seems to hold a much weaker grasp on people. The reasoning part of the brain is far more willing to test information coming from the outside for accuracy and finding reasons that it shouldn't be accepted, likely owing to the risks of being misled by others. So tying this together, we can say that on an adaptive level, it appears good to be able to persuade other people of things, whether those things are true or not. And you want to find reasons to persuade other people about those things because it's good as a sender of information. And it also appears to be bad to be persuaded by other people of things which are false, but good to be persuaded by other people of things that are true. Or at least it's better to be persuaded of things that are true. What counts as adaptive depends on your role in this interaction. Are you a sender of information or are you a receiver of information? If you're a sender of information, it's adaptive to have as many arguments in favor of your point as possible because that makes you better at persuasion. If you're a receiver of information, now you want to be more skeptical of reasons against accepting that information because you don't want to be misled. Because again, talk is very cheap. Speaking of our role in this interaction, let's shift gears a little bit to cases where people have some skin in the game. That is, in the previous studies we're discussing, again, we're talking about relatively abstract reasoning problems, testing hidden rules about random strings of numbers. That's all well and good in the general sense, but most people probably don't care at all about that topic. Let's instead consider cases where people care more deeply about the outcome of a discussion, what conclusions are reached, and talk about what's known as motivated reasoning. Motivated reasoning reflects cases where, as the name might suggest, people are motivated to ensure that a particular conclusion is reached. It's similar to confirmation bias, but not exactly the same thing. And motivated reasoning could entail the utilization of confirmation bias, where people are predominantly searching for evidence in favor of their own view, but it may also result in people discounting evidence that doesn't conform to their preferred conclusion. Now, what's particularly interesting about motivating reasoning is how the definition of the term implies, or in some cases even states, that our reasoning abilities are somehow being disrupted by our emotions or our existing beliefs. That is, we're not talking about reasoning anymore, we're talking about motivated reasoning, a bias, a disruption, a problem, a flaw. And the reason that this is interesting, again, is that it tells us about this implicit functional framework that people are holding. Namely, that the function of reasoning is supposed to improve people's ability to find truth or enhance the accuracy of their information. However, according to the argumentative function put forth by Mercer and Sperber here, persuading people about things we already believe or hold emotional involvement in is in fact part of the function of reasoning itself. Motivated reasoning is not a flaw, it's just reasoning. And we saw an example of motivated reasoning in our last lecture on morality when we were discussing abortion. To refresh, as we mentioned, depending on your preferred sexual strategy, the availability of abortion may seem like more of a cost or more of a benefit in terms of getting what you're after. If you're the type of person that would prefer the costs of casual sex remain high, you probably dislike abortion being available. Whereas if you would prefer the cost of casual sex to be lower, you might like the availability of abortion. Whether abortion counts as a positive or a negative thing in the world largely can depend on your personal contexts, your strategic interests. However, your strategic interests, things like this is good for me and people like me, that might not be a particularly convincing reason that's going to persuade other people to join your side of the dispute. So instead, you may end up with arguments that sound persuasive, but they aren't always targeted at uncovering true underlying principles or things that you really believe. For instance, you might hear arguments like, life begins at conception, abortion ends that life, ending life is murder and shouldn't be permitted. You might hear all those reasons voiced by the same person that also says, but there can be exceptions in the case of rape and incest. And this is indeed a very common stance. Most people seem to agree that there can be exceptions to abortion law in contexts of rape and incest. But if we string these reasons together in a logical fashion, you end up with the statement, there should be exceptions to murdering your child in cases where they're going to be born through rape or incest. Which is something people would rarely agree with. So you end up with a set of reasons that might sound persuasive independently, but not necessarily uncovering some true principle when you string them together. So as such, when people are reasoning about whether abortion is good or bad, we can end up mired in disagreements as our reasoning abilities tend to start being focused on persuasion rather than some objective answer or some overall improvement in outcomes or discovering truth. Both sides have strategically different best interests, and so endorse or generate whichever arguments seem the most intuitively appealing or persuasive to others. So to see this in action, we can consider a study by Kahan in 2013 entitled Motivated Numeracy and Enlightened Self-Government. Fun title. In this paper, the authors wanted to figure out why people tend to get wrong answers to questions and considered two different explanations. Why are people getting questions wrong? So the first explanation is that people were, in a word or two, and I'm going to take some liberties here on the language, are people getting questions wrong because they're ignorant or stupid? Is it an information problem? That is, if you ask people questions like, are GMOs, genetically modified organisms, safe to eat? or is climate change real and caused by human activity? You're going to get a series of different answers from people, many of which will be affirmative or negative. In short, some of those people are going to be wrong. Some of them have to be because they're giving you different answers to the same question. Might they just be wrong because they lack information about the topic? Or might they be wrong because they lack the ability to reason about the topic? Because if people lack reasoning skills, it doesn't really matter what evidence you feed them, they can't get the right answer. But if it's just an information problem, if you feed them the right information, they should be able to get the right answer. So why are people getting the question wrong? Is it because they lack information, or is it because they, alternatively here, are biased, in a word? Is it because they just don't have the right information, or because they're not trying to find the right information? Are people reaching different answers about climate change and abortion and GMOs because they're biased in favor of a particular conclusion? That is, let's say you have a particular social group you happen to be a part of, and this social group believes certain things. Or these people have some deep-seated personal interest in a conclusion being accepted by others. If these people have a particular conclusion in mind that they want to see reached, they may have all the tools at their disposal to objectively assess evidence, and they may have the evidence as well. They might have the tools, the reasoning ability, and the evidence, but instead of changing their views on the basis of this information, they would instead engage in motivated reasoning and either make the evidence fit their conclusion or discard the evidence. So again, just to keep this in perspective, they're trying to ask the question, when people get answers to questions wrong, is it because they lack the ability to get it right, because they lack reasoning abilities or information, or are they getting it wrong because they're biased? And it doesn't matter if you give them the right information, because they're not going to pay attention to it. So how did they test this experimentally? So in the first of their studies, the researchers here gave about 1,100 participants a numbers problem to solve. And the numbers problem goes like this. Sometimes people develop unpleasant rashes on their skin. And when that happens, there are a variety of creams and lotions designed to help heal the rash, remove it, get rid of it. However, we want to know if the treatments actually work. After all, some rashes will go away on their own, or some will get worse over time. And some rashes may go away after treatment or get worse after treatment. We want to know, do the hand creams and lotions actually work? So we're going to do what any good scientist does here. We're going to conduct an experiment. Some people are going to use the hand cream and others won't, and we're going to track who gets better and who gets worse. So this is what our experimental results tell us. Of the people who used the skin cream, 223 got better and 75 got worse. And of the people who didn't use the skin cream, 107 got better and 27 got worse. From this, can we conclude that the skin cream works? This is the problem the participants are faced with. A little bit of division with these numbers tells us that, in this case, among those who used the cream, 3 people got better for every 1 that got worse. And among those not using the skin cream, about 5 people got better for every 1 that got worse. And if you compare these ratios, we can conclude that the skin cream is not effective. If anything, it's having the opposite result. It might be making the rashes worse. So what's good about this problem is that it's mathematical. There's an objective conclusion we're supposed to reach based on these numbers. And everyone should be able to agree on this conclusion. But were participants actually able to solve this correctly? And that depends. If they were high in numeracy, that is, are they good at working with numbers? The top 10% of people in numeracy we're able to solve this problem about 75% of the time. If you're really good at working with numbers, you're more likely to get a numbers problem right. No real surprise there. But it's also worth noting that people usually don't have some bias in favor of saying skin cream did or didn't work. Because you can flip the math on this so the skin cream works or the skin cream doesn't work. People tend to get the right answer if they're good with working with numbers. They have no bias in favor of finding a yes or a no answer. Now, the interesting part here is what happens with the next numbers problem they gave people. The problem was identical in its setup and the numbers, but there was a key difference. Now, instead of talking about skin cream and rashes and the outcomes, the same problem was framed as one in which some cities enacted concealed carry handgun bans, that is, anti-gun legislation, and some cities didn't do that. And in some cities, crime got worse, and in some cities, crime got better. So the participants are now asked to find out, was the gun legislation law effective in reducing crime? Exactly the same setup as, is the lotion effective at reducing the rash? How well did they do with this problem? Well, that depends, again, but overall performance dips substantially. Whereas the high numeracy participants were getting their answer 75% right in the skin cream condition, only 57% of the numerate subjects were getting the answer right with the gun legislation crime question. It's as if the very numerate subjects, the ones who are very good at working with numbers, it's like they suddenly got a lot worse at working with numbers. Substantially worse at working with numbers. And when they broke the responses down by political affiliation, it makes it a lot clearer what's happening here. While overall there's not much of a difference in numeracy between the most liberal of the Democrats and the most conservative of the Republicans overall, there was a clear difference whether the data fit that group's general preferred political conclusions. Conservative Republicans, at least here in the US, tend to be in favor of gun ownership and against gun legislation. Liberal Democrats tend to be in favor of gun restrictions and in favor of gun legislation. So, when the data fit each group's preferred conclusion, their numeracy ability mattered. If you were a liberal Democrat and you were good at working with numbers, if the numbers showed that reducing gun ownership reduced crime, a very politically palatable conclusion for you, you were far more likely to get that answer right than if the results showed that restricting gun ownership increased crime, which is a politically unpalatable conclusion. And this was, of course, reversed in the conservatives. If the conservatives saw that gun restrictions made crime worse, the most numerate ones tend to get the answers right. If they saw gun restrictions made crime better, the more numerate ones ended up getting the answer wrong far more often. And interestingly, this gap was the largest in the people who were the best at working with numbers. Again, taking some rather colorful liberties with my phrasing here, the smartest people in the room seemed to be better at being dumb when the evidence didn't fit their conclusion. They had all the skills they needed to solve this problem correctly. They had all the information they needed to solve this problem correctly, but they simply didn't use those skills and information as well if it meant they were going to reach the wrong or less palatable conclusion. And importantly, this difference did not appear in the skin cream rash conditions. When the topic was socially and politically neutral, both very numerate Democrats and Republicans were likely to use the information and reach the correct answer, and they started to agree with each other. So this method of reasoning, one in which you have the right tools to solve the problem and you don't use those tools, is clearly not superior for landing on more accurate beliefs. If you want more accurate beliefs, you would honestly consider the evidence for and against your own ideas. However, this fits very well in the framework of attempting to persuade other people. If you want to make this less academic, you can also think about political debates that either you have witnessed or that you have personally engaged in. And perhaps most crucially, you can think about political debates you never witnessed or very rarely witness. Because the silence from the latter group, the silence of some debates, can be particularly telling. The lack of those debates can be very informative. That is, let's say you encounter someone and they're discussing what political candidate they support in an upcoming election. If our reasoning abilities were really just about improving the decision-making process, you might ask them why they're voting for the person they're voting, interrogate their reasons for voting for who they're voting for, and ensure they're really making a good choice regardless of whether the person they're voting for is someone you support or you detest. However, that's not usually how people seem to deploy their reasoning abilities. I believe ample personal experience will reveal that people overwhelmingly attempt to uncover and discredit the reasons people vote for political candidates that they don't support. That is, if someone is supporting, let's say, Jim for president, and they hate their opposition Tom, pro-Jim, anti-Tom. If they found someone that said, awesome, I too support Jim and hate Tom, very rarely do you see the first person begin to ask them, oh, well, why do you agree with me? Why did you reach the same conclusions I did? To ensure that this other person's reasons are accurate. Those two people are already on the same side of a debate, and so they don't try to argue each other out of their position. However, if they encounter someone that says the opposite, I love Tom and I hate Jim, this is where the arguments and the reasoning tend to begin. Taken together here, you see a whole lot of noise made by people when they encounter others they disagree with, and a whole lot of silence when they encounter others that they happen to agree with. And both the noise and the silence are telling us something about the function of reasoning. After all, just because someone is supporting your side in a debate, that doesn't mean they're supporting it for the right reasons. If you support tax breaks for the rich because that's good for you, and you hear of someone else who supports tax breaks for the rich, you don't tend to start debating them to find out if it's actually in their personal best interest to support the thing you support. They've already concluded the same thing you do, and so there's no argument and no reason to reason with them. As Mercer and Sperber aptly note, people often are not trying to form an opinion when they're evaluating evidence. A lot of times they already have an opinion. What they're actually looking for are sound, persuasive reasons for it. And this becomes doubly troubling when that opinion gets stated publicly. Because when your social reputation begins to ride on the accuracy of that opinion, now you're motivated not just to persuade others so they believe what you do, but also to persuade other people to not think you're a big dummy for saying something wrong. And so you kind of stop evaluating evidence against your position and start finding whatever reasons you can to support your own position. And this can be where the phenomenon of groupthink arises, or where you see communities that start locking themselves into opinion-insulated bubbles, where they seem to get crazier and more polarized as they spend time around each other. Because within these communities of like-minded people who all agree, some reasoning might take place, but it's not argumentative reasoning. What they're trying to do, in the rare cases they talk about points against their position, is to try and rebut the other side, try to prove the other side wrong. And everyone keeps reasoning towards the exact same conclusions, which is where you find all this confirmation bias and motivated reasoning. And as these groups spend more time around each other and everyone is agreeing with each other and everyone is presenting more reasons to accept the same conclusions they all agree with, people keep finding, unsurprisingly, more and more evidence that supports their conclusion, which makes them increasingly confident in it. Because after all, if everyone I'm around agrees with me, would so many people really be wrong about this thing? And this is where that phenomenon of polarization and groupthink really starts to kick in. Because you're surrounded by so many people that seem so smart because they're providing evidence for things you already believe. And surely they wouldn't all be wrong, right? But funnily enough, the answer to the question, would everyone I'm surrounded with, be wrong? The answer to that question seems to depend on what those so many people think. That is, we might all be capable of thinking that our beliefs must be well supported because everyone in our group agrees with us. But if there's a different group out there and all of those people happen to hold a different belief, well, naturally that's because everyone in that group is biased and deluded and incapable of seeing the truth that our group knows. And a reasoning mechanism that was focused purely on improving our cognitions probably wouldn't do that. So when everyone's arguing in favor of the same conclusion, and everyone has that same vested interest in reaching that conclusion, the arguments from the other sides really stop being considered as serious arguments anymore. And it's precisely in those cases where reasoning is not known to improve our performance, to improve our outcomes, to improve our accuracy. In fact, when there are so many people that are rejecting arguments from the other side, even hearing arguments from people who disagree with you can actually increase your polarization, your belief more. That is, you believe A, you hear a reason against A, and then you come to believe A even stronger. And why does that happen? Well, that's because in this like-minded group of people, argument A from the other side is presented, but it's not really considered. People just start presenting reasons to not think about that argument, to discredit it, to rebut it. But what about this? The person who said it's a bad person, you can't trust them. And because people aren't arguing, they accept these reasons. And hey, my argument just stood up to a counterpoint. Well, this must mean my argument is even stronger than I thought it was. After all, if your belief faced a counter-argument and survived, well, that must mean your belief is really sound. It's even more sound than you initially thought. It's only when people have different arguments in mind and everyone has an interest in finding the correct answer does our reasoning tend to improve our outcomes. And this is all a very social process. To the extent that we reason on our own, inside our own minds, to improve our own cognitive outcomes and our own knowledge, to the extent we do that at all, it seems to be more a byproduct of our ability to construct these arguments that other people find persuasive. And sometimes it works, because it is easier to persuade people of things that are true relative to persuade them of things that are false, all else being equal. But it's just difficult to do that alone because people do not spontaneously argue with themselves. Not really. Now, relevant to our group here, there's another finding that I want to highlight, discussed in this paper. Comes from Gilovich in 1983. And it's entitled Biased Evaluation and Persistence in Gambling. This finding concerns people that have made a bet on the outcome of a sports game. In other words, these are people who have a vested interest in the outcome of that game. They have money riding on it. What happens when you tell people the outcome of this game they bet on, and the outcome meant they lost their bet? What they try to do is explain why they should have won instead. That is, they'll start referencing some events within the game that should have made the game and their bet turn out differently. Statements, things like, I would have won if only that interception didn't happen. I would have won if only this player didn't suffer an injury in the middle of a game. When they lost, they tend to do that a lot. However, when these people actually won their bet, when the outcome of the game was, congratulations, your team won, here's your money, they tend to accept that win at face value, treat it as an expected outcome. And even in some cases, they talk about why they should have won even more, why the win should have been even more extremely in their favor. Overall, if you look at how much people talk about these outcomes, people spend more time than expected talking about their losses and why they shouldn't have lost, and a lot less time talking about their wins. And the second study they reported on in this paper looked at fluke plays that occur during a game. Fluke plays are things that are very atypical. This usually doesn't happen, but it happened in that game. In other words, you can think of it as a random outcome. So these people who are betting on a sport game, and there was a fluke event that occurred during that game. Did those people who were rooting for a team that ultimately lost because of that fluke use the fluke to explain why they shouldn't have lost? Absolutely they do that. So let's say injuries in games are very unlikely, and there was an injury during this game and it meant your team lost. How did people reason about this? Well, they reasoned that this fluke event usually doesn't happen, and it swung the course of the game, and because of that, I should not have lost this bet. The game should have ended in my favor. But what happens when the fluke favors them? There's a very unlikely event that happens, and it means their team wins. Did people say that they shouldn't have won? Absolutely they don't. They take this fluke as part of a justified reason that of course they were supposed to have won their game. And this should be sounding very familiar to any player or viewer of online games. How often have you encountered someone else playing a game, losing it, and then blaming that loss on some events in that game, whether they were random or not? If only this thing didn't happen, I would have won. If only I had better teammates. If only this random outcome didn't occur. I was going to win this game. I can't believe I lost it. Because players of these games are invested in the outcome personally, and because losing is not a good outcome for them, they are actively looking for reasons to explain their loss in a way that seems like they actually really were or should have been the winner. However, when they are the winners, it's far rarer to see them blame their winning on getting lucky or some other rare event. People are reasoning in very counterfactual ways here, not very good at finding truth. You lost your bet. Reasoning about why you should have won isn't going to help you win the bet. Not going to change the outcome of the game. But reasoning about why you should have won might persuade other people that you should have won. It might persuade them that you are more talented, you are more skilled than your performance dictates. When people do win, they're not trying to spontaneously argue about that. Of course I won. That was expected. That was supposed to happen. And on top of noticing other people do this, how often have you noticed yourself doing it? That is, if you play these games, how much do you find yourself reflecting on your losses as things that really shouldn't have happened? As your losses being due to external factors, things like luck or chance, and causing yourself grief or anger over it. After all, if you were expected to win, if you know you should have won, but you lost, that's quite a break in expectations, and that's causing a great deal of frustration. When your opponent's only winning because they're abusing something in a game that shouldn't be there anyway, or they only won because they're using this really cheap tactic, or they only got lucky, or they got the right teammates and you didn't, or whatever else you can blame on, doesn't that just make the loss sting all the more for you? Because it was a win that you were robbed of. It was a cost inflicted upon you. In some cases, it was even a moral wrong done to you. But people reason about this not to try and change the outcomes usually, but to persuade other people that their skills in this game are On their sports bet, their social investment value is actually higher. I shouldn't have lost, I should have won, I just got unlucky. But if I did win, and this supports my conclusion, let's not reason about that too much. We can take this at face value. And to end today, I wanted to share a very short story from my life when I was more of an academic. I wanted to share this particular story to let you know that, as we saw before, even very smart people aren't free of these biases. In fact, far from it. Us smart people can be very good at these biases. And I also wanted to share this story with you to let you all know how smart I am and how my genius has only been held back due to other external biased factors in the world, naturally. And this story concerns when I was attempting to publish a paper on a topic known as inequality aversion, which is this idea that people dislike inequality itself, and they'll work to reduce it. People are averse to inequality itself. I found this idea of inequality aversion implausible. It didn't seem like something people could have been selected to do. And so I examined the paper that was proposing it. I looked at their methods. And in doing so, I discovered a key confound in their methodology. It prevented the authors from reaching the conclusion that they thought they did in an obvious way. That is, their conclusion might have been true, but there was a hole in their reasoning about the topic. And we can already see here that my reasoning abilities were being engaged because I was engaging in an argument. It was a largely one-sided argument at this point, but it was an argument. I was trying to prove someone else wrong and faced with a conclusion I did not want to accept. So what I started to do is examine the reasons for this conclusion, to set out and prove someone else's idea wrong, or at the very least, to prove their idea incomplete. And I did just that. I went out, I replicated the finding in their paper, showing that their initial result did hold up, but also showed that in more contexts, when you added some additional situations here, it became clear that people weren't actually averse to inequality itself. Instead, what they seemed to be averse to was suffering losses. They were fine with inequality that wasn't generated through losses. They only seemed to punish inequality that came from losses, and they punished losses in general. They didn't punish inequality that resulted from someone being better off. So people clearly weren't averse to inequality itself. So, with my result in hand, I wrote up my paper and I sent it out to the journal that had published the original article I was critical of and arguing with, because I figured this journal had a natural interest in publishing this kind of work, so why not start there? Unfortunately for me, before scientific papers get published, they have to go through a review process, where usually about 3 peer scientists are going to review your work for methodological soundness and see if it's worthy of publication or not. And unfortunately enough for me, one of the people reviewing my paper was the original author of the paper I was criticizing. Enter motivated reasoning. Science is this method for improving our accuracy of knowledge. But scientists are humans, and these humans want things like status and money and jobs and promotions and to not be proven wrong after stating something publicly. So as such, the first response I received from this original author I was criticizing, that was now in charge of determining whether my paper got published, the first response I received from them is that my study should not be published because it was too similar to their original work. So, I responded. I explained what the key differences were between my paper and theirs. And the second comment I received back from this reviewer said, now my work shouldn't be published because my work was actually too different from theirs. So here we went from, you shouldn't publish this paper because it's too similar, to, you shouldn't publish this paper because it's too different. And when I pointed out this contradiction to the editor of the journal and suggested there might be some conflict of interests here, what I thought was a very sound point on my side, my article ended up getting rejected, and I had to go publish it in a different journal instead. So while reasoning can be this wonderful tool for determining truth, again, because it's easier to persuade people of things that are true than of things that are false, generally speaking, the outcomes of reasoning do not always point in that direction of making things more true. If you think of reasoning as having a different function instead, one aimed more at persuading people, a lot of things that seem like biases and flaws begin to look a lot more like expected features.